And that said, next on stage, we're going to have Chris Biscardi that is going to be talking about GraphQL with Go. Round of applause for Chris.
Cool. Hey, how's it going? I'm Chris. I'm going to talk a little bit about GraphQL today. Yeah, let's get into it. So who am I? Why should you listen to me? I'm Chris Biscardi. Spent a couple years building the UI team at Docker. Spent the last, say, 2 or 3 years since Relay came out, working with GraphQL. Currently, I basically work with startups from 2 to 30 people, do a lot of GraphQL stuff, a lot of JavaScript, a lot of Go. So, yeah. And today, when we talk about APIs, and we're talking about GraphQL, right? So we're obviously talking about APIs. I want us to think about who we're building the APIs for, right? Because an API itself doesn't matter if nobody's using it. So if you build it such that nobody can use it, then have you really built anything useful? No. And then on top of that, what do we build these APIs with? And how does that impact the people who end up using it? So the major players in the space right now are sort of like REST, gRPC, and this sort of new kid on the block, GraphQL, right? And what I want to emphasize is sort of like GraphQL is not necessarily a replacement for REST and gRPC in your service-to-service infrastructure. It's more of a really good tool for placing in your API gateway level, and then having any external users, any clients, any UI, any GUI, any CLI tools talking through that layer to the rest of your infrastructure. So let's take a minute to talk a little bit about REST and talk a little bit about why you might want to move away from it. So REST has been around since, say, 2000, since the paper came out, popularized a couple years later. And really, REST gives a lot of rise to sort of conversations about what REST is, right? If you start talking about REST, immediately everybody needs to define it, which I'm not going to do, so. And sort of continuing on that thread, when you go to deploy a REST service or build a REST service and architect it, the problem, or one of the big problems, is sort of like there's this leveling to REST. And nobody ever really gets to the end, right? Nobody ever really gets to that like hypermedia, Helios, like you don't need to know anything about the server before you start using the API level of REST, right? And it's become this architectural concept that's boiled down into a couple GET requests, a couple PUT requests, mostly POST. If you get that lucky, you know, some people are just like abusing GET repeatedly. And you end up needing to think about these resources and the ideas on the end of those resources. And then you have sub-resources on those resources, but should they be sub-resources or should they be top level? How do we actually access them? And then we actually have these things below them that we actually need, but they don't really relate to the sub-resource directly. They're just like mostly that sub-resource. And you end up with these sort of like rigid, manually nested URLs that can get quite long, right? And you end up with sort of like, okay, we need to add something, but just for the iOS client, right? So we're gonna add, on the end of sub-resource 2, this iOS underscore like snapshot URL. And it's turning into sort of like RPC, but like, we're gonna call it REST anyway. And then there's the issue of HTTP, right? Like REST isn't technically tied to HTTP, but 99% of usage of REST is all HTTP. And then you go and you're like, okay, so how many of the verbs do I use, right? There's get, put, post, delete. Like, which of these are you gonna use? How are you going to explain them to people? When you go and you put into your API, and then somebody else is like, okay, what's the difference between post and put? Sorry. Then you have to explain the difference to them, right? And they aren't gonna have the same definitions that you are, and the other senior engineer or senior architect on your team isn't gonna have the same definitions as you. So it turns into this sort of like extremely large decision-making process. And this is actually one of my favorite REST diagrams. It is the flow diagram for the decision-making process of the Erlang Web Machine REST toolkit. So I encourage you to blow this up, poster size, check it out later if you want to. But the point here is that there's a lot here, and when people use these APIs, they boil them down to, did I get a 200XX response, right? Like there aren't many people looking for 201s. There aren't many people looking for anything really other than a 404, right? Like if it's a 500 something, it's a server error. Like we don't care. And then when you start talking about documentation for these things, it's all very manually generated, or it's sort of slipshod on top. So if you start using something like Swagger, you're sort of like mapping this sort of pseudo type system onto your REST API in a way that doesn't really match up very well, right? And it's sort of the same problem where if you've ever worked in JavaScript land, they're trying to like put type systems on top of JavaScript with like TypeScript and Flow, right? And they never really match up really that great. So like you don't get the type benefits of a language like Go if you're using one of these systems that's just sort of like patched on top. And then there's the issue of sort of like overfetching, right? Even if you get past everything else, we're going for REST, we're going for HTTP, you still have these sort of inherent problems with it, right? You make a request, but you get back 50 fields. You get back 50 fields, and one of them is like 30 megs of JSON for some reason. Like somebody included that field, and you can't get rid of it because, you know, the server team didn't implement sparse field sets. Like, they exist, but really, not too many people actually implement them, right? So again, in practice, overfetching is a real problem. And then there's the converse to that, which is underfetching, right? So you make this REST request to an endpoint. You get back some list of fields, and one of those fields has a list in it, and that is a list of IDs, right? And now, like, what you really wanted is that list, right? So maybe you're making a to-do app because, you know, you're learning a new technology. And then you get, like, a list of to-do IDs. Well, that's not really what you wanted, right? You can't construct a list to show a user from a list of IDs. You have to make another n requests to get all of the data for all of those to-dos and check whether they're done, et cetera, right? And like, if you're getting back IDs, it's good if you're getting back IDs, because if you're not getting back IDs, you're probably getting back URLs. Like, somebody went hypermedia on you, and now you have to hit 50 different URLs instead of taking all of these IDs and making me hitting like a multi-get endpoint once. So there are solutions to those problems, but like in practice, most people don't apply them, right? There's no sparse field sets, there's no expand APIs. And one of the other issues with REST is it sort of pushes you towards resource-intensive architectures, right? REST will push you into a backends for front-ends architecture. And there's nothing wrong with this architecture pattern, but it means that you have to basically have a team for each of the APIs that you want to support, right? Which means that you have to have a team for the API for the UI. So every time you have a new UI, you have a new backend. And every time you have a new API for that UI, you have a new team. So now you're sort of just expanding the number of people that you need to support accessing all of basically the same data, right? So that iOS snapshot turns into a team supporting the iOS endpoint. And then there's gRPC, which, how many people are familiar with gRPC in this audience? It's basically everybody, yeah, it's a Go conference, right? And gRPC is great, right? It gives you authentication, it gives you async and sync, it gives you some cancellation and timeouts, like, it's a useful tool. But it's useful when you control the whole stack, right? If you don't control the whole stack, you don't really want to be giving like a public gRPC endpoint to your users to then connect to. No, maybe you do, but. And then there's a gRPC web, right, which is 1.0 as of, I think I checked this morning, and it was 3 days ago. So if you really like living on the edge and you're like fully bought into gRPC and that's everything, like your Java services, your Go services, everybody, your JavaScript, endpoints, like everything is talking gRPC, maybe this is a solution for you, but in the wider scheme of things, it's probably not a solution for everybody. So, why GraphQL, right? And I want to stress that it's GraphQL not to the exclusion of these other technologies completely. It's GraphQL as the main client-server interaction. So when we talk about why GraphQL, we sort of have to talk about when should you use GraphQL. If it's not going to replace everything, when is it going to be used? And what I would tell you is that it should be used when your API is a product, right? If you're going to have a team building this API that other teams are going to be building products on top of, and you're treating this API as this business object layer that everybody talks to, that's when you want GraphQL. REST typically ends up getting bound to database schemas, right? So you end up like auto-generating your REST endpoints, and they end up being tied to the way that you define your database tables because that's the easiest way to do it, right? You're just auto-generating everything, and then your UI is tied to like this field name in a table somewhere. And going back to the documentation point, GraphQL is strongly typed, right? Like Go, it's strongly typed. Therefore, we can generate automatic documentation for it. We can put autocomplete in editors, right? If we can introspect this schema, then we can take that information and do interesting things with it. We don't have to write all of our documentation in Markdown anymore. And we don't have to try to layer something like Swagger on top, because we have the actual type information that we need. And this is an example of using sort of this strongly typed introspection information to build a UI that you can use to interact with any GraphQL API, right? So if you look on the left of this screen, there's a GraphQL query, if you've never seen one. Slightly to the right of that is the response of that query. And then the whole white part is like an expandable sidebar that you can click through that shows you the types and the responses that everything in the GraphQL API expects. So inherently, by building a GraphQL API, you've already documented all of the fields and all the properties and everything that you can do without having to lift another finger, right? And then you can do, obviously, more, which you should, and actually include some documentation strings and descriptions, but you don't have to. So that brings us to sort of the intro to GraphQL, right? GraphQL is a query language. It prioritizes types over endpoints. So REST is very endpoint based, right? You hit this URL, you get this response. GraphQL is very type based. I want a user. I want a to-do. I want whatever my business object is. We get powerful dev tools from this introspection of ability on our schema. And it lets us have a bit more powerful API evolution. So if you've ever worked with gRPC and you've ever worked with protobufs, the way that a GraphQL API evolves is very much like a protobuf API. So you deprecate things over time. Maybe you have some analytics to tell you if anybody is ever using that. So GraphQL basically comes in three parts. You describe your data, and this is using the GraphQL SDL. If you've written a Go struct, this looks very similar. It's not exactly the same, but it's similar. You've got your primitives, you've got your keys, you've got your type declarations. After you've defined what the data looks like, you can ask for what you want from the GraphQL server, right? So GraphQL is a query language that looks a lot like JSON. It looks like JSON without the values, right? And there's these little function call looking things in there, but it's all declarative. You're not actually calling any functions here. And then you get predictable results, right? So with REST, you get back whatever blob the server decides to send you. With GraphQL, you get back exactly what you asked for, right? There's no overfetching, there's no underfetching, and on the server, that means that for every client you ever have hitting your server, you can determine whether they're using a specific field or not, which means you know whether you can deprecate it or not. So talking a little bit about the SDL, you have your typical scalars. You have required fields, which are marked with an exclamation point. You have your arrays and things like that. Any sort of map type is going to be a struct-ish kind of thing. And then there's also arguments for mutations and things like that. And this gets a little bit more complicated. You can use things that are called field directives, which we'll talk about a little bit later. But more or less, GraphQL schema is roughly equivalent to writing Go structs. So now we're getting into the actual like Golang related part, right? What libraries can we actually use to build a GraphQL server in Go and do it efficiently as possible? And I'm telling you that you should go check out GQLGen. And there's a couple other libraries that you can also check out. And GQLGen was recently sponsored in development by 99 Designs, so it's nice to have a little bit of backing in the GraphQL library that you use. So what is GQLGen? GQLGen is a schema-first GraphQL library. So the SDL that we just saw before is how we define our APIs. And then we define resolvers that map to that schema. It's type safe. So GraphQL is strongly typed, Go is strongly typed. We don't want to lose any of that. We don't want map string interface, right? You'll never see that with GQLGen. It's all strongly typed. And it's code gen based, right? So when I say that we're writing the GraphQL schema and then we're generating some code and then you're using that code to build your server, you're code genning a lot of stuff that you would otherwise need to manually sort of hash out and write. So if we're talking about how to use it, you go get it just like any other library. There's an extra go get here for a go generate command. Not super important. But since it's schema first, let's write a schema. Since we're learning something new, let's write a to-do app because that's what people do. And hopefully, from what I explained about the SDL before, you can sort of read this already, right? You sort of ignore the gaps between the Go struct and the schema language, and it looks roughly the same. And then there's these types called mutation types, right? So there are some types where we want to make a mutation on one of our objects, or we want to create one, we want to update one, we want to delete one, whatever. And we have these one-off objects that accept, say, like an ID, or like an ID and a name, or whatever, right? They're not necessarily types that we care a lot about. They're sort of these transitional, somebody sends us something and then we transform it into the thing we actually want types. And like I said, if you look at the type declaration in the schema for the user, it looks a lot like this Go struct, almost exactly, actually. So then we run the code gen. Now we've written our schema.graphql file, we run the code gen, and we can run GQLGen to update any of the code gen if we want in the future. You get this YAML file, because I'm sure after working in the Kubernetes ecosystems, all of you love YAML, right? Great. So there's this YAML mapping file that lets you sort of declare which files go where and how you want to map models to types if you want to do that. So if you already have sort of like a database and like types associated with that database, you can map the GraphQL schema to those database types using this YAML file. So it's not code gen to the exclusion of all else. But this allows us to build a resolver map. And a resolver map is basically a set of functions that get called when you want to access a field on one of these structs. The code isn't super important, so I'm just going to go through it. But you can see that this input type, this input struct that we have, was part of the auto-generated models that we got from the schema.graphql file. So the sort of transitional type that we don't really care about a lot, like it's not something that we need to feed and maintain, and like it's just this thing that we need to exist for a very temporary, brief period, was auto-generated for us, and we don't need to worry about it. And then all the resolvers get stubbed out for you, right? So you don't need to think really hard about, say, like, okay, we have a to-do, and then there's a user that I want to access on the to-do. And like, anything that you've written in the schema.graphql file gets stubbed out as a resolver for you. And you can see that these are basically just Go structs with functions on them that get called, right? It's a very simple way to think about fetching your data. And in this case, r.todos is just a field on a struct that we defined. It should be a REST call or a gRPC call or a database call. So then we have our like mutation resolver, right? So when we're talking about this input type, this transitional input type that got constructed for us, this is where we're using it, right? And then we're constructing an actual to-do and storing it in our database and then returning the list, right? And it's important to stress that this can be like arbitrary code. You can do whatever you want here. And this context object contains a lot of the GraphQL meta information if you want to do more complex things. And then our GraphQL server is very similar to any other server that you've ever started and run. We mount it, and we run. And the playground that we saw before is included in this library. So you don't need to worry about setting any of that up. You just include this one line and you get the playground. And this is what a GraphQL query actually looks like, right? So you name the query, you specify which fields you want. It looks like a compressed JSON object, right? Like there's just keys, there's no values. And this specifies exactly the data structure that you're going to get back, right? So I'm gonna have a to-dos key, I'm gonna have a user key, I'm gonna have the name key on that user. So I know how to access the data that I'm fetching, as opposed to something like REST, which sort of just returns you blobs, right? And GQLGen is sort of at 0.6 right now. So the Go GraphQL ecosystem is still fairly early. The JavaScript ecosystem is the main line, like it matches the spec closest because there's a bunch of companies working on that. But after working in the JavaScript ecosystem a lot over the last couple of years, I strongly believe that what's emerging in the Go ecosystem is a stronger path forward for building and maintaining GraphQL services. So there's a couple extras that we can talk about. There's directives for skip and limit. You can build your own custom directives. There's a lot of really advanced stuff that you can get into for authorization and things like that. You can restrict the way that people query these schemas based on the complexity, and you can weight different fields with different complexity. So if this thing takes 20 seconds to actually go fetch the data, and this thing takes, I don't know, like a nanosecond or whatever, because it's just returning something, you can weight those differently when people are actually making the query and stop them if they're making too complex of a query. And then there's a couple more extras that are a little bit more advanced, such as there's still this n+1 sort of selects problem, and now we're actually on the selects problem, right? Because we've made the one query to the GraphQL server, but we're still hitting our database or something from the GraphQL server. So how do we deal with these SQL queries that, 101 selects? We don't want 101 selects, we want 2 or 1, right? And the way that you deal with that is called data loaders, which I won't get into because I'm running out of time here. But thank you. And if you have any questions, I'll be around.